So, what is structural engineering? Structural engineering is part of engineering that focuses on making sure buildings, bridges, aircraft, and other structures are safe, stable, and able to handle all the forces they face every day. It combines physics, math, materials, and design to make sure are both reliable and efficient. Structural engineers make decisions that protect communities and support the world we live in. As someone studying here at UC San Diego, I see how structural engineering connects creativity with problem solving, and that is what makes it such an important field. Continuing forward on the civil structures sequence focuses on designing buildings, bridges, and other infrastructures that support cities. There's a need for this sequence because society relies on safe structures that can handle earthquakes, wind, and constant use. Engineers in this field often deal with questions about load pass, material weaknesses, sustainability, and how much cost affects design. A major concept in civil structures is structural analysis, which helps engineers understand how forces move through a structure. Career paths involve building design, transportation infrastructure, construction engineering, and consulting. Civil structures keep cities standing safely and efficiently. So moving forward, we have also the geotechnical focus. So the geotechnical sequence studies how soil and rock behave and how the ground interacts with structures. This focus exists because every building needs a foundation that can safely support it, and the ground can behave in unpredictable ways. Engineers in this field encounter problems like soil settlement, landslides, and retaining wall failures and slope stability. A key concept is soil mechanics, which predicts how soil carries loads. Career paths include foundation design, earthquake geotechnics, tunneling, levee design, and landslide mitigation. Geotechnical engineering protects communities by making sure structures are supported by safe, stable ground. Okay, moving forward, we also have the aerospace structures focus. So, the aerospace structure sequence focuses on designing the structural parts of aircraft, rockets, spacecraft, and drones. There's a need for this sequence because aerospace structures must be extremely strong while staying lightweight. And they also face intense forces during flight. Engineers in this field deal with questions about material strength, aerodynamic load, vibration, fatigue failure, and how different components behave under rapid temperature changes. A key concept is composite materials, which are used because they offer high strength with low weight. Career paths include aircraft design, spacecraft engineering, defense systems, UAV development, and advanced materials research. This field pushes the boundaries of what technology can achieve. Next, we also have the structural health monitoring focus. Structural health monitoring, also called SHM, focuses on using sensors, data, and technology to constantly monitor the conditions of structures. There's a need for this sequence because early detection of damage can prevent failures and reduce repair costs. Engineers working in SHM deal with questions about sensor placement and data interpretation, real-time monitoring, and distinguishing normal behavior from damage. The key concept is called vibration analysis, which helps detect cracks or weakening before they become dangerous. Career paths include smart infrastructure development, aerospace monitoring, bridge health detection, and artificial intelligence for engineering systems. SHM brings intelligence into structural engineering. Okay, lastly, we have which focus sequence interests me the most. And out of the four sequences, honestly, I'd say the one that interests me the most is aerospace structures. I've always been drawn to how engineering and flight come together, and I enjoy the combination of physics and high performance materials and advanced design challenges. Aerospace structures demand creative problem solving and push engineers to innovate in ways that can change technology for decades. The idea of contributing to aircraft or space systems motivates me, and choosing this sequence aligns with both my curiosity and my long term goals. Thank you.